Hi everyone, welcome back to Life with Technologies YouTube channel, and thank you for watching and supporting this channel. So this is part 2 of our Nokia Lab simulation series, and remember in part 1 of this series we have discussed the basic CLI command that you can use to operate and manage Nokia devices. So remember to check it out, and in this episode we'll be focusing on how to implement link aggregation on Nokia routers. Before we dive into the lab, we first need to understand what link aggregation means. So link aggregation is a very common networking application that bundles multiple physical Ethernet links between two devices into one logical links. So we are taking multiple Ethernet links, the physical Ethernet links, and we are bundling them into one logical link. So you could be having 1 Gs or 10 Gs or 100 Gs, and then you combine them and bundle them into one logical link, which we are calling the link aggregation group. So this one helps to increase the capacity and improve network redundancy. So when you are bundling two 10Gs into one lag, you end up having 20 gig, depending on the configuration, depending on how many active links you have configured for the lag. So this one helps to improve the capacity, and it also improves the redundancy of our network. Remember, when you are bundling these multiple links into one logical link, in case one link goes down, the other links can be able to handle the traffic. So the traffic from the link that is down will be distributed on the link that are up. So this one helps to improve on our network redundancy. And one thing I have to mention is that when you are setting up the link aggregation, you also need to lag ports that are on different cards. So don't lag ports from the same line card. You always have to distribute the links to different line cards. So this is the lab setup. We have two routers. We have router 1 and router 2. And between these two routers, we have three links. We have C1, C2, and C3. So we'll be bundling these three links, these three Ethernet links into one link aggregation group. And we'll configure an interface on the routers and test the connectivity between the two routers using the link that we have aggregated. So for the implementation steps, the first step that we need to do is we need to configure the physical port on the two routers. So I'm logged into the two routers. I can show port. You see we have this number of ports. They are all shut down, both admin state and the link state. They are all down. And these are 100 G ports. On router 2, we can do the same. I can show port. See that we have this number of ports and they are all shut down, both admin and link state. So on Nokia, all ports are shut down by default. So whenever you are bringing up a new link, you need to manually unshut the ports, especially the admin. The admin state, it's shut down by default. So you need to manually unshut the ports. So the configuration that we need to do on the ports, we first need to configure the connector, the breakout for these 100 G ports. So in this setup, we are just using 100 G ports. So that's why we are configuring the breakout to be 100 G. You can configure the breakout to be 10 Gs. You can configure the breakout to be 1 Gs, depending on the requirement of your network. And this is how you configure the breakout. So you have port 1, C1, that is, we are configuring it to be 100 G port, and then we are unshutting the port. We are doing the same for port 2. We configure the breakout and then we unshut the port. So this is the first step of the configuration. You need to configure the breakout ports on the router and the connector. So I will configure our router R1. So there are different views, so we must be in the configuration view for us to be able to run these commands. So on R1, remember this is like the user view, so we need to be in the configuration view, and you will see that Nokia uses a hierarchical architecture. The syntax is hierarchical, so you need to ensure you are in the right hierarchy when you are making the configuration changes. So these are the configuration: configure port, exit, breakout. So I'll paste. I'll just exit again, exit, and run the same configuration. We have something here. We have exit. I'll correct that and then configure, so that is okay. We have configured the 3 ports, connector, the breakout, and then we have shut down the physical ports. So once we have done this, we also need to configure our breakout ports. So remember, we are just using 100G ports, so we also need to make configuration for the ports. So for the port configuration, we are giving a description. This is how you give a description. You just need to, so it's configure port C11, and the description is to R2 this port. So you need to give meaningful description to your ports. And then under the Ethernet, these are where we are configuring some logical parameters for the ports. We need to enable LLDP. This is the link layer discovery protocol, a very common used protocol that will help us to see the information of directly connected devices on this local device. So you need to enable LLDP. It will help you when you are troubleshooting. So this is configuration for port C1. So I'll copy this, go back to our router 1, but we are still in the configuration view. I'll paste, exit. We can configure port 2. Let me scroll down. On port 2, we are doing the same. Configure port. Then we need to enable LLDP, give a description under the port. So I'll do similar configuration. I'll paste. And then finally we have port 3. So we have this. Copy it, copy, then on this I'll paste. So we have configured the 3 ports. I can show ports. Now we see that we have 3 ports. The admin state is now up and the port state is also up. You can see the MTU, the port mode. The port mode can be different. We can have network, we can have hybrid, we can have access depending on the setup of your network. And then we have the 100G details. So we have the 100G base. So these are 100G ports. You can adjust the MTU, you can adjust the port mode depending on the requirements of your network. So we have already finished interface configuration on, this is router 2, we were to configure on router 1. But this is still okay. Let me just check. I will exit, admin display config. So for this part 1 configuration, they are almost similar, just that we need to change the description. So this is the only thing that you need to change, the descriptions, but everything else remains the same. So we'll do similar configuration on R1. First, we need to configure the connector. So we'll configure the connector. Let me scroll down. So we configure the breakout on R1. You can see all the ports are down. So let me just verify the config. We need to add. So we have configured the connector. We now need to configure the breakout ports. So I will copy these. Let me scroll down to here. Then we can paste on R1. We are still in the configuration view. We can verify that all our configurations are okay. So I'll paste. We can show port. So we also have 3 ports up. So I can display the link layer protocol, display system LLDP neighbor. We have 2 ports that are already up. We have 1 port that is still down. Let me see again. Show port. So we have 2 connections that are up. Show port again. On R2, I will show system LLDP neighbor. Let's display the configuration, admin display config. Just to verify the LLDP configuration on that first port. So port 11C1, we have missed one command, the admin status txrx. So what I can do is I can copy this, copy, and then configure port. We already have the port. Configure port 11C1. We need under the Ethernet, and then we have LLDP. Add mark, can do info, destination mark, nearest bridge. And then we need to admin status txrx. That is it. So if I do show system LLDP neighbor, we also need to do same for R1. So configure port, this is the port. I copy and paste 11C1, Ethernet LLDP, check info. So destination mark, nearest bridge, admin status txrx. Show info. So let's see again, show system LLDP neighbor. So we now have the 3 ports interconnecting the 2 routers R1 and R2 are up. So you can see that with LLDP information, we are able to tell that this port is connecting to this port on remote system is R2, and even we are getting the remote MAC address for the remote router. So this is very handy when you are setting up your network or setting up new links. You will be able to see all this information. So once we have done the LLDP and port configuration, we need to move to the next step. So the next step is to configure lag on the 2 routers and add the 3 ports. So remember, we have 3 ports interconnecting the 2. So we'll configure lag and then add these 3 ports in our lag. So you can see, you can configure, then lag. So this is the lag ID. You can check on the router how many we can configure. So configure, see that configure lag, then a question mark. We need to enter the lag ID, and the lag ID should be from 1 to 800. So we are configuring lag 1. So I will copy this configuration and paste on R1. Then we also need to shut down the lag, and we are using LSCP. And then you need to configure the administrative key, which is many times you'll be merging from both ends. So I will copy this. So LSCP will be used to manage the status, to check the status and monitor the status of our lag. So that's why we need to configure LSCP. So on R1, can paste, configure lag 1 description. We also give it a description to lag 1 router 2. Port, then LSCP and administrative key. So I will paste. I can run this command show lag 1 description. you can see that the operation mode, this one is still down. We can show lag description. Show lag description, you can see that we have only one lag. Show lag detail gives us the detail of the lag. So lag ID 1 mode, it's a network. Operation is still down because we haven't configured the remote device. The mode is active, LSCP, enable. So we can configure the second router. So I will copy this and configure our R2. Control copy on R2. I will exit all. Remember, we have the exit all command. So I can paste the configuration. We are configuring lag 1, the description, and the 3 ports are bundled into this lag. So I'll paste. So I can show lag. We have lag 1, show lag detail. You can see that we have 3 ports and the capacity. Let's see the details. Operation mode is network. Operation is up. Show lag 1 description. You can see many more details. So when we check on R1, remember when we checked on R1 before, it was down. So we can run the same command, show lag detail, and you can see now our lag is up because we have configured both ends. And the priority is 32768, the default. Active standby, active operation is up, admin is up. So our lag is configured. The next step is now to configure a router interface. We configure a network interface and bind the lag onto the interface. So the same way we did on Huawei, you have to configure an interface, and then under that interface you can assign an IP address and bind the lag that we have configured. So if we check on this router, if I show router interface, we only have the system interface without IP address, and both V4 and V6 are down, admin is up. So we need to configure a network interface between the 2 routers, and it's very simple to configure network interface. These are the configuration. You run the command configure router interface, and then you give it the name. So the interface name will be to R2. And then we are assigning IP address of 10.10.10.0/31. We give it a description, and then we bind the port. So it's port, then we are binding lag 1 that we have configured. And then we can now shut down the interface. So I will copy this, go back to R1, paste. We can do info. So we have address assigned, description, the port is bind to the interface, and then we have and shut down the port. So we can do the same for R2. So we are configuring an interface to R1 and assigning an IP address. So on R2, I can run the same script. Info, verify that we have the right IP, exit. Then we need to save the configuration. So I will run the command admin save. We'll also do the same on R1. So once we have done this configuration, I can run the show router interface, and now we expect an interface. This interface to R2, it's up. Operational state, you can see that V4 is up, V6 is down. We haven't assigned IPv6 address. The mode is network, and the port it's lag 1. So on R2 we can do the same. Show router interface. and it will give us an output of all the router interface that we have configured on this router. So we can test our connectivity. We can try to ping. So on Nokia, we run the same command, the same way we do on Huawei. It's ping.0. We are able to ping. On R1, we should also be able to ping 10.10.10.1. We are able to ping the remote router. So this one means that our lag setup is okay, our configurations are okay, and we are able to communicate between the two routers through the lag that we have configured. So this is how simple it is to configure lags or link aggregation on Nokia routers. And we normally use it on a service provider network, enterprise network, and even some other applications. We always have to do link aggregation to ensure that we achieve higher capacity and also network redundancy. So I hope you have enjoyed this session. If you've enjoyed it, please click that like button, and remember to subscribe to our channel and stay tuned for more upcoming videos on Nokia Lab simulations. Thank you.